Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 3 on Newton's second law, and it says two boxes A and B having masses 8 kg and 4 kg respectively are placed in contact next to each other on a horizontal rough surface as shown below. Then we can see the diagrammatic representation of that. Then below here it says a horizontal force of magnitude F is applied to box A and the system accelerates uniformly to the right. The net force acting on block B during its motion is 12.5 Newton, and the coefficient of kinetic friction between each block and the surface is 0.2. Take the motion of the system to the right as positive. Then 3.1 is saying state Newton's second law in words. So we know that when we say Newton's second law states that when a net force acts on an object of mass, the object will accelerate in the direction of the net force, where acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So that's how you are expected to define Newton's second law according to your CAPS document. Then 3.2 says draw a label-free body diagram to show all the horizontal forces. Note that it is only 2 marks. We only ought to show the horizontal forces. No vertical forces should be shown here. So the horizontal forces acting on block B, since we are told that the two boxes are in contact next to each other, we know that B here is experiencing the force of A. So we know that we're going to say B is experiencing the force of A. So this is force of A on B, right? And then to the opposite direction of motion, it is obviously experiencing the kinetic frictional force, because remember the blocks are in motion, and then we are being told of the coefficient of kinetic friction, which means of course these blocks are experiencing kinetic friction, right? So this was your 3.2. That's all you needed to do. Show horizontal forces. Then 3.3.1 says calculate the acceleration of the system, right? We are told of the net force here. They say the net force acting on block B. So this concerns block B, right? Is during its motion is 12.5. Now that means if we want to find the acceleration, we can just calculate the acceleration by using the information on block B. Now we know that if we find the acceleration in block B, this will be the exact acceleration on block A, because remember these two objects or these two blocks are moving as a system. And for blocks that are moving as a system, they have the same acceleration, right? So remember that for blocks moving as a system, the acceleration is always the same. So now you can just go F net is equals to MA. Now consider that we are using block B, right? We are using block B. So we are told that the net force on block B is 12.5. And then the mass for block B is just 4. Then we are looking for the acceleration. So we can divide both sides by 4. Now our acceleration is 3.125 meter per second square, right? And then since they said acceleration, we can just say to the right, because remember, acceleration is a vector. So we need to have both magnitude and direction, right? Then for 3.3.2, they say the magnitude of the kinetic frictional force acting on block B. So again, we are still on block B. Then we know the formula to calculate the kinetic frictional force is just Fk is equals to mu k times n. We are given the coefficient of kinetic friction. When we read here, it says the coefficient of kinetic friction between each block and the surface is 0.2. So that means we have 0.2 here as our coefficient, and also as well here it's 0.2, because remember both of these blocks are moving on the same surface, right? So that means the coefficient of friction in both the surfaces are the same. But then note that this doesn't mean that block A and block B are experiencing the same frictional force. They are experiencing different frictional forces. It's just the coefficient of friction is the same because they are moving on the same material or the same surface. Then, okay, Fk, that's 0.2. But then now our normal force, we don't have our normal force. But then you will note that if we have an object just moving horizontally like that, and then also the force is being applied horizontally, then we know that if we have to show our vertical forces here, we have the normal force, and then down here we have the gravitational force, which tells you that the upward forces are always equal to the downward forces. So that means to find your normal force, we would only need to equate this to our gravitational force. Then this is m times g. Now we are still on block B, remember? So this is 4 multiplied by 9.8, right? Then what is 4 multiplied by 9.8? That's 39.2. So the value that we just got here, we're just going to substitute it to our n. This is our normal force, right? So we'll say 0.2 multiplied by 39.2. Right. So here we were just trying to figure out the normal force so that we can substitute in here. Now, when we multiply the two, this gives us 7.84 newtons. And this becomes your kinetic frictional force. So always note that I said whenever it comes to calculating the kinetic frictional force, when you are given the coefficient, always note that the first thing that you'd have to do is find the value of the normal force. Then you can substitute it in here to get your kinetic frictional force, right? So it is always the trend with these questions. Then 3.3.3, it says calculate the magnitude of force that block A exerts on block B, right? So if you can just allow me to erase only just this part here. The magnitude of force that block A exerts on block B, as we can see here, this is what we are talking about, force A on B. So this is the magnitude of force that block A exerts on block B. This is what we are trying to calculate. We are trying to calculate the magnitude of this force here. So what can we say? We can just go F net is equals to mass times acceleration. But then remember, if we are still using block B, we've already deduced that the F net for block B is equals to 12.5 newtons, right? So that means we can just come here and substitute all of this. Remember, all of this is equals to your F net, right? Then we can just come and substitute this part here, m times A, with 12.5 newton, because that is equivalent to the net force. Now, to indicate this, remember, this is the positive direction. Since we are told here, take the motion of the system to the right as positive. So to the right is positive and to the left is negative. Now, at this point, we need to say the force of A on B minus the frictional force that block B experiences. Then this is equals to 12.5. Remember, our net force is 12.5. And then this is what we are looking for, force of A on B. But then we do have the kinetic frictional force. That's the one that we calculated above here in 3.3.2. So let's substitute. We got 7.84. And then this is equals to 12.5. Now, at this point, we can all agree that we need to take the 7.84, transpose it over to that side. So that's 12.5 plus 7.84. Now, having to deal with that one, the force of A on B is now equals to 20.34 newtons, right? Then just like that, you have calculated the magnitude of force that block A exerts on block B. So that's how you were supposed to tackle this question for a total of 13 marks, guys. So make sure that you play the video as many times as possible and try to understand the approach that I took in solving this. But then with all that being said, please hit that subscribe button if you've been watching the videos and haven't subscribed. Then if you found this lesson helpful, please press that thumbs up button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.